How is experimental probability similar to and different from theoretical probability? Think about this question during the lesson. Talia and Yoshi chose a spinner game for the school fair. They planned for 1 out of 8, or 12.5% of the players winning a prize. During the school fair, they kept track of the numbers of total players and winners, and they recorded the data in the table shown here. How does the actual number of winners compare to the expected number of winners? The first step is to find the experimental probability of winners during each time period. In this case, the experimental probability is equal to the ratio of the number of winners to the total number of players. We can find the experimental probability for each time period and for the total number of contestants. The experimental probability from 10 to noon is about 10 3/10%. The experimental probability from noon to 2 is about 13 7/10%. So the experimental probability for the entire day will be between 10 3/10 and 13 7/10. For the total number of contestants, the experimental probability is 58 over 475, or about 12 2/10%. The second step is to compare the theoretical probability to the experimental probability of winning the game. Which value is greater in this situation, the experimental probability or the theoretical probability?
Select your answer.
The experimental probability of winning the game is 12 2/10%. This is slightly lower than the theoretical probability, which is 1/8 or 12 1/2%. You can write a proportion to find the number of people expected to win based on the theoretical probability. The theoretical probability, 1/8, is equal to the number of people expected to win, x, divided by the total number of players, 475. Multiply both sides of the equation by 475. Then simplify. About 59 players were expected to win. The table shows 58 winners out of 475 players. The experimental probability is pretty close to the theoretical probability of winning this game. There was one fewer winner than expected. Now you know how experimental probability is similar to and different from theoretical probability.
During the second day of the school fair, Talia and Yoshi recorded 43 winners out of a total of 324 players. How does the actual number of winners compare to the expected number of winners?
So we have 43 winners out of 324 players, and so we're comparing the actual the experimental with the theoretical. So if we finish the theoretical, I keep confusing them. If we finish the experimental, we do 43 divided by 324, and we get about 13, and they round it excuse me, to the 10th place in the example, so I'm going to do the same. So it'll be 13 3/10%. The experimental probability happens to be, if you look at the example, the theoretical probability was 12.5 or 12 5/10%. So the experimental probability is more, that is greater than the theoretical probability. So there were more winners than expected.
Marcus rolls a die 3 times, and it lands on an even number each time. He then increases the number of repetitions and records his results. What happens as the number of repetitions increases? Is the die fair?
The theoretical probability of rolling an even number is 50%. If the die is fair, then after more repetitions, the experimental probability will better approximate the theoretical probability, and that means that they would be more likely to be the same. Marcus can roll the die many more times and record the results. So the first 3 times that he rolled the die, it landed on an even number. So that's where they got 3 and 3. So as of right now, 100% of the time, theoretically, he's going to roll an even number. Then if he rolls it 10 times, theoretically, he's going to get 7 even numbers when he rolls. Then he rolls it 20 times. Out of that 20, he gets 8 times to get an even number. And then last here we have 100 times he rolls the dice, and 48 times he is able to get a even number. So at 48%, that's the experimental probability, because he's rolling the dice. So 48% is not too far off from the theoretical 50%. So that means the die is actually fair, because as he continues to roll the dice, it gets closer and closer to that 50% that they identified as the theoretical probability.
Marcus rolls a die many times and records the number of times he rolls a 6. Is the die fair? Explain.
The theoretical probability of rolling a 6 is 1 out of 6, because there are 6 sides to the die and there's only 1 6. So the percentage of rolling a 6 on a die would be dividing the 1 and 6, and that would give you approximately 17%. So theoretically, 17% of the time you'll roll a 6. But if you look at the experimental probability, as he continued to try this out and roll the die, the percentage kept decreasing, and it is decreasing away from the 50%, and it's going, it went down and then it went back up. So it's seemingly that it won't be anywhere close to the theoretical percentage of how many times you would roll a 6. So to answer the question, is that die fair? No, that die is not fair.
Amir and Marvin each flip a coin 50 times and record the result of each flip. The tables show their results.
Part A. Based on theoretical probability, what are the expected results of 50 coin flips?
We have Amir's results, Marvin's results. So the answer, based on theoretical probability, excuse me, there are 2 possible outcomes, head or tails. So half the time you should be getting heads, half the time you can get tails. So the probability would be half, or 50%. So after 50 flips, the result should be about 25 heads and 25 tails. So we look here, and it says now, why might their results be different from the expected results based on the theoretical probability. And it says theoretical probability can be used to estimate results, but does not guarantee results. The more times they flip their coins, the more likely it is that their results will be closer to the theoretical probability.
Amir and Marvin continue until they each flip a coin 200 times. How do you expect Amir's results and Marvin's results to compare? How will their results compare with expected results based on theoretical probability?
As Amir and Marvin continue to flip the coin, their probability of flipping heads or tails should be getting closer to the theoretical probability of 50% of the time. They will get one or the other. So as they continue, the theoretical and experimental should be not exactly, but close to the same percentage.